Hello everyone, I'm Jiangang from China. It is a bit late, it is a bit now. Thanks for your patience. I have been working on open source software more than 10 years. I was used to be a maintainer of our kind of project, which is a very famous test framework around the world and supported by Red Hat. And now I'm spending more time on openEuler community, and as I'm a member of openEuler user committee. Today I want to share a new technology. We call it distributed Softbus, and we can share the computing power and the data by it. Okay, let's get started. I will follow this context to introduce this technology. In general, the Linux platform provides the most basically communication technology. But this technology, traditional IPC mechanism, only provides the basic capability and they are not friendly to the end user. Such an example, the pipe can only be in half-bit duplex mode, and the single is a way to handle the ascending event. The shared memory supports transfer the largest amount of data, but it requires the same four to work together. So if we want to share computing power and data, depends on reliable communication mechanism. Of course, we have some new technology such as DBus, but it also has its disadvantage, such as it is suitable for the graphic user interface, but it's not suitable for data transmission, and it has multiple vulnerabilities, and such as UBus. So what we need is not only the IPC methodology, but also the cross-platform and feature-rich middleware framework. This page, I want to talk about the orange, the distributed Softbus. We all know the hardware bus in microcomputer, right? The hardware bus comprises the CPU, memory, and other peripherals together, and it transfers the data and control the information is passed on this hardware bus. And the hardware bus has very typical features such as plug and play, high bandwidth, and so on. So we get inspiration from the hardware bus. So we decide and develop the distributed Softbus. We want to build an invisible channel between the different devices with different protocols and with different transmission rates. Okay, in fact, we have a big plan. We plan to develop ecosystem intention based on the distributed bus. The distributed bus masks the difference of the different protocols and different devices. Now the Softbus supports the Internet, Wi-Fi, WiFi, Bluetooth, and other protocols. Based on the distributed Softbus, we develop connection of distributed components, such as the distributed data, distributed file, and based on this layer, we develop some scenario-based distributed service and mechanism, such as remote control and data sharing. So the end user can use the distributed capability, the uppermost layer, to develop their own application. It's very convenient. This page shows the design and the architecture of the distributed bus. At the bottom, we can see the Softbus needs the bound driver in kernel. Based on the kernel's layer, the middle layer shows the Softbus the most core functions such as tuple management and authentication, messaging, and data transmission, and other very important features, service management, and so on. The upper layer, we provide some higher level functions. At the right, I give an example about the calculator, about the distributed camera. At the outside the openEuler exhibition area, I give another example for the distributed calculator. If you have interest, you can experience it by yourself. This page, I want to talk about the innovation brought by the distributed Softbus. In general, if we want to develop an application, in general, we should create the socket, both the connect end and the server end, and then we can bond and listening to the ports at the server end, right? And then we repeat the circles of sending and receiving. It looks more complex and yeah, it's not convenient. So let's look at the distributed. If you use the distributed bus to develop your own application, in this way, the registering and the callback is a very important mechanism. We can register the function and listener on the server end, and when if there's data from the connect end, the server end will call the callback function to process these data. So it's very inconvenient and cost the users work done. This is an example I just mentioned last second. You can experience at the openEuler exhibition area. The mathematical expressions can select the suitable device to calculate, yeah, right? According the mathematical expressions complexities. At the bottom layer, we use the distributed bus, and based on distributed bus, we use a distributed data subsystem to support the distributed collaboration. Yeah. This is an example. This is a video to show that example. Okay, let's play. You can see the mathematical expressions. Yeah, it's a collaborative case, and you can you can operate it by yourself and the openEuler exhibition area. And last, I want to talk about the next plan and invitations. We want to support more protocols, such as the industry protocols, and increase the maximum of device connections. The value is 20 now. And we want more distributed softbus can be run on different Linux distribution, such as Ubuntu and CentOS and so on, and other distributions. And we hope more programs know this technology and use and contribute to distributed softbus. I posted the main page of openEuler. If you have any interest on this technology, please join us. Okay, that's all. Thank you.